Hi girls, today we are going to see about equilibrium of rigid bodies. So what is equilibrium? Equilibrium means the body is at rest without any motion. That is called equilibrium. So it doesn't mean that there is no force acting on the body, but actually when you keep anything on the table, there will be two forces acting. For example, if you keep a book on the table, the gravitational force acting on a body vertically downward and the normal force exerted by the table on the body upward. So there is one downward force and there is one upward force. So they both will be same, and so there is no net force. So we cannot say there is no force, but there is no net force. And so what about mechanical equilibrium? Mechanical equilibrium means both the linear momentum and angular momentum remain constant. So linear momentum means momentum in straight line. Angular momentum means momentum in rotational motion. If both of them are constant, then the body is said to be in mechanical equilibrium. So when the linear momentum is constant, that means the net force acting on the body is zero according to law of conservation of momentum. So F net will become 0. Similarly, that is in translational equilibrium, the vector sum of different forces, that is if you take F1 vector, F2 vector, F3 vector, these are the forces acting on a body. So when you take the sum will become 0 because they act in different directions, and when you take the sign convention, then they will become 0. So F1 vector plus F2 vector plus F3 vector up to Fn vector will become 0. Similarly, if you resolve them into horizontal and vertical components, each force F1 vector, F2 vector, F3 vector, if they are resolved into horizontal and vertical components, here also the resultant of these components will cancel each other. And when you take angular momentum, the angular momentum is constant when the net torque acting on the body is 0. That is tau net vector will become 0. That is the body is said to be in rotational equilibrium. Here also the vector sum tau 1 vector, tau 2 vector, tau 3 vector becomes 0, which act on different directions. So when you see the vector sum, tau 1 vector plus tau 2 vector plus tau 3 vector up to tau 1 vector will become 0. So here when you see both the cases in translational equilibrium and in rotational equilibrium, F net is 0, also tau net is 0. So the net force and the net torque will become 0 if the bodies are in equilibrium. And next we are going to see about different types of equilibrium and their conditions. There are 7 types of equilibrium: translational, rotational, static, dynamic, stable, unstable and neutral equilibrium. And so when you see translational equilibrium, that means a body is at rest and it is not at all moving. That means a linear momentum is constant, net force is 0. Since it is translational, you should consider linear momentum and force. And in rotational equilibrium, angular momentum is constant, net torque is 0. And static equilibrium means linear momentum and both angular momentum are 0, net force and net torque are 0. So here since it is in static equilibrium, static means it is at rest, so the momentum, both the momentum will become 0. Whereas in dynamic equilibrium, the body is moving but it is in equilibrium, so linear momentum and angular momentum are constant, and the second point is the same, net force and net torque are 0. And next, stable equilibrium. For this you can consider one example. You take a bowl like this and keep a small ball in the bowl, and if you bring the ball to the end of the bowl, the ball will fall again to the bottom. So here what about the linear momentum and angular momentum? Both are 0 because this is in stable equilibrium. And when you see the ball, when it is brought to the top side, that is to the end of the bowl, it will again come to the bottom. So the body tries to come to equilibrium if slightly disturbed and released. Also the center of the body shifts slightly higher. When the ball is moved up, the center of mass of the body is shifted slightly high, whereas the potential energy of the body is minimum and increases if disturbed. When you see the ball is brought to the top end of the bowl, the potential energy actually increased. That's why here it is given. And here unstable equilibrium means the bowl is now in the inverted position and the ball is at the top, and when you disturb the ball it will fall on the ground. And so here when you see this example, you can understand these 4 points. First, the linear momentum and angular momentum both are 0. The body cannot come back to equilibrium if slightly disturbed and released. When you see this small ball, it cannot go back to the original position. And also here the center of the body is slightly lower. So when you see it is at the bottom, so the center of mass of the body shifts slightly lower. Here also the potential of energy of the body is not minimum, it decreases because the ball is now on the ground. So actually the potential energy is decreased. So only if it is at certain height it will have maximum value, but since this is on the ground, when you see mgh, the h will become 0, so the potential energy is 0. And for neutral equilibrium, you consider a ball on a ground. So here the linear momentum and angular momentum are 0 as in the previous cases. The body remains at the same equilibrium. When the ball is moved, it will be in the same equilibrium, and the center of the body also does not shift. Here you see it will be on the same ground, so the center of mass of the body is not raised or lowered. Here also the potential energy remains the same even if disturbed. Here when you see it is on the same ground, so the potential energy also remains the same. So these are the 7 types of equilibrium and the conditions for them. Next we are going to see about couple. Couple means 2. So if there are 2 forces acting which are equal in magnitude but opposite in direction, and the 2 forces have no same line of action of force. When you see this diagram, you can understand. Here C is the point where it is pivoted, and A and B are the 2 edges of the rod, and A is given a force, downward force, and B is given an upward force. Because of that, the point A and B, both of them will experience an anti-clockwise direction of force. And here in this, when you see, both the forces are equal in magnitude but they are opposite in direction, and they have some perpendicular distance between them, and such a force will create a couple. You can take the car steering, the example for this. In the car steering, you are applying the force like couple, and here when you see, the net force acting on the rod is 0 because they cancel each other. And so here both the forces at A and B will act in the anti-clockwise direction. And so what is a couple? A pair of forces which are equal in magnitude but opposite in direction and separated by a perpendicular distance so that their lines of action do not coincide, that causes a turning effect which is called a couple. So couple means a turning effect. When you open the bottle and when you use a car steering, here we are applying the force called couple, and couple is nothing but the turning effect. And next we are going to see about principle of moments. Here you see there is one rod pivoted, and F1, F2 are the 2 forces acting downwards, and the normal force will be in the upward direction. And for translational equilibrium, that means the rod should be at rest. For that you should have N is equal to F1 plus F2, that is upward force. N must be equal to the sum of the downward forces. Then only it will be in translational equilibrium. So N is equal to F1 plus F2. And for rotational equilibrium, the net torque must be 0. That means D1 F1 must be equal to D2 F2. Here you know D1 is the distance between F1 and the pivoted point, and D2 is the distance between F2 and the pivoted point. And so for rotational equilibrium, D1 F1 must be equal to D2 F2. Here this equation is called as principle of moments. And suppose there for when you use a beam balance, you can have d1 is equal to d2 and f1 is equal to f2 for equilibrium. And here the f1 is usually taken as load and f2 is taken as effort, and f1 by f2, according to this equation, f1 by f2 will become d2 by d1. Suppose if d1 is less than d2, that means you will get greater advantage. So f1 is larger and f2 is smaller. That means you could lift a large load with a small effort. So this ratio d2 by d1 is called a mechanical advantage of the simple lever, and the pivoted point is called fulcrum. So here this point is called as fulcrum. The center point is called as fulcrum. And mechanical advantage MA is usually given by d2 by d1. Hope you understand this. Next we are going to see about center of gravity. And suppose if we take a rigid body like this, there are too many forces acting, gravitational forces are acting, W1, W2, W3, W4, W5, etc. And all these gravitational forces will act at a common point C, which is taken to be as W. So this W can be assumed to be the resultant of all these forces, W1, W2, etc. And so this point C at which all the parallel forces will act, the resultant of all these parallel forces act, is called center of gravity. So how can we define center of gravity? So the center of gravity of the body is a point at which the entire weight of the body acts irrespective of the position and orientation of the body. So this is a definition for center of gravity of the body. Now we are going to see about a method to determine the center of gravity of a uniform lamina but having an irregular shape. So here this can be found out by trial and error method. Here when the body is supported at the center of gravity, the sum of the torques acting on all the point masses of the rigid body becomes 0. So here when you take a lamina and it is supported on a small point, and here suppose if the body remains horizontal, that means a body is in static equilibrium. So here this point is called center of gravity because a body remains horizontal. This is one method. There is another method to determine the center of gravity of an irregular lamina. For that you consider this lamina, you take 3 points P, Q, R. First you suspend from point P and draw a line, that is P dash, and again suspend from the point Q and find out the vertical line. Again suspend from the point R and find out the vertical line. Now all these 3 lines will meet at particular point, and this point is nothing but center of gravity. And so this is another method to find out the center of gravity of irregular lamina. And next we are going to see about bending of cyclist in curves. Suppose a cyclist negotiate a circular level road, it is not banked. So in the previous part we have studied about banking of curved tracks. That means the raising of the outer edge of the road is called banking, and here the road is not banked, and it is a circular path of radius r, and the cyclist is moving the speed v. And so here when you see this diagram, here the point C, when you see, that is the cycle and the man have considered to be a single system, and C is a center of gravity of both the cycle and the man. So here C is nothing but the center of gravity. Now you consider the x-axis YC and the y-axis YZ, and here mv square by r is nothing but centrifugal force. This is pseudo force which acts outward, and this is balanced by the frictional force F, which is acting inwards towards the center of the circle, and mg is acting vertically downward of the system, and n is, you see, the normal force which is acting upwards, and here theta is the angle made by the system with the horizontal. So when you see the force diagram, here this is the force diagram, and here I have told you mg, weight acting downwards, mv square by r is a centrifugal force, and F is a frictional force, and n is a normal force. Theta is the angle between the normal and the resultant, that is a angle made by the cyclist with the normal. And so here the alternate angles are equal. So again this angle is theta. So you find out sin theta from this. Sin theta is nothing but AB by AC. Here AC is a hypotenuse. Similarly cos theta is equal to BC by AC. And when the body is in rotational equilibrium, the net torque must be equal to 0. So here when you see this force mv square by r, this will act in anti-clockwise direction, whereas the force mg is in clockwise direction. Usually the clockwise turns are taken to be negative and anti-clockwise turns are taken to be positive. So here the equation now becomes minus mgab, that is force into perpendicular distance, because torque definition you know, torque is nothing but force into perpendicular distance. So here the force is mg and perpendicular distance is ab. So here negative sign because the turn is in clockwise direction. So minus mgab plus mv square by r bc, where bc is a perpendicular distance. Here when you see the diagram, bc is a perpendicular distance for the centrifugal force. So here both of them when they are equated will become 0 for rotational equilibrium. So mg ab is equal to mv square by r into bc, and here you find out sin theta and cos theta, and so AB will become now AC sin theta and BC is equal to AC cos theta. Substituting all those values, and M and AC get cancelled, and so you will get tan theta is equal to V square by RG. You know sin theta by cos theta is equal to tan theta. So when you take theta, theta is equal to tan inverse V square by RG. Here V is velocity, R is the radius of the circular path, and G is acceleration due to gravity. So this angle should be taken to stay in equilibrium. So here this angle theta must be kept by this man to stay in equilibrium. So this is the bending of cyclist in curves. Hope you understand, girls.